All right, let's go ahead and get started. Everybody knows everybody, so Nina, just take it away.
All right, so thanks again for coming. And thanks to Andy and to the Prindle Institute and DePauw for inviting me to give this talk. The talk is titled A Scientific Realist's Guide to Objective Chance. I'm going to use the terms objective probability, chance, and objective chance all interchangeably. I'll probably go back and forth in between them throughout the talk. There is a handout, which Jason's going to pass out. Great. So one of the main goals of this paper is to convince you that there is such a thing as objective probability. Sometimes when we make claims like it's extremely likely that such and such happened, it seems like all we're doing is making a claim about our degree of belief in that proposition being true or in that event occurring. Okay? We're making a claim about ourselves and our relationship to the world. So as an example, if I had a heavily biased coin, a coin that was much heavier on one side than the other, such that most of the time when I flip the coin, it lands heads. And suppose that I just flipped the coin, but I have yet to look at it. Okay? So it's sitting on the lectern here, but I haven't looked at it to see which side ended up, I haven't looked to see how it landed. Okay. In that sort of situation, I might say it's extremely likely that the coin landed heads. And there it looks like I'm really making a claim about my degree of belief in the proposition that the coin landed heads. There's some fact of the matter. Either the coin landed heads or it didn't. It's just that I don't know which one it is. I don't know which of those facts actually obtains. But some philosophers and physicists seem to think that sometimes when we make claims about what is likely to happen or unlikely to happen, we're making a stronger claim. We're making a claim about what the world is like independent of us, the evidence that we happen to have, the things that we happen to believe, so on and so forth. Okay. Making sense of that is a challenge, but here is possibly a good case. If I'm holding my heavily biased coin in my hand, but I have yet to flip it, and I say, it's extremely likely that when I flip this coin, it will land heads. It looks like it isn't the case that there's some fact of the matter about how the coin is going to land, right? Or at least on a plausible interpretation of what's going on. There's no fact of the matter about how the coin is going to land. So it isn't that there's some fact that I'm ignorant of, and I'm expressing sort of my degree of ignorance by saying that it's extremely likely that the coin is going to land heads. It seems like I'm saying something about the coin itself, something that would be true even if I had totally different evidence about the coin, or I had very misleading evidence about the coin, even if there were no sort of human subjects that had been thinking about the coin at all, making some objective claim about the world. That's supposed to be a case, depending on how you fill out the details, of objective probability or chance. Okay. Physicists and philosophers have been very skeptical of this notion of objective probability or chance. They want to know what it is out there in the world that could underwrite claims like, oh, it's very likely that the coin is going to land heads, even though there's no fact of the matter about whether or not the coin is going to land heads. The title of my talk, A Scientific Realist's Guide to Objective Chance, is referencing a very famous paper of David Lewis's from the 1980s called A Subjectivist Guide to Objective Chance. And what Lewis was doing in that paper was he was picking up on this idea that people would really, really like to do without objective probability. Okay? They would like to be able to explain it away. Or another way to put the same point is that metaphysicians are comfortable accepting the existence of objective probability only insofar as they can tell a story about what those probabilities are that is in some way acceptable. So they're only willing to accept the existence of probability insofar as they can explain how probabilities turn out to be not such a weird thing after all. So what I'm going to be doing in this paper is not just arguing for the existence of objective probability, but also arguing that that sort of approach, Lewis's type of approach, is, if not definitely mistaken, there's at least some significant pressure not to approach metaphysical questions in that kind of way at all. Okay, so I'm going to be trying to also make this more general point about methodology in metaphysics, and in particular, the kind of methodology we should follow in metaphysics insofar as we are scientific realists, insofar as we take science to be, and not the only example of good inquiry into what the world is like, at least sort of a paradigm example of successful inquiry into what the world is like. Okay, so I want to start with a really prosaic observation, and that is that we use probabilities all the time in everyday reasoning to explain facts about frequencies. So we say things like the following on an everyday basis. We say, someone asks, why is it that you've never seen the roulette ball land on the same number twice in a row? The answer seems to be, it's extremely unlikely for the roulette ball to land on the same number twice in a row. Why is it that a fair coin lands heads roughly half the time when you flip it? Because the probability of the coin landing heads is 1/2. Why is it that I never hit only green lights on my way home from work? Because the probability of only hitting green lights is very low. Okay? Those kinds of explanations should sound totally everyday and normal to you. If we take that kind of reasoning seriously, if we think those are legitimate explanations, then it looks like right away we're committed to objective probability. Right? Because whatever else we think about things like roulette wheels and coins and traffic lights, we don't think that our degrees of belief explain how they function. Okay? So insofar as we are successfully explaining why the roulette ball never lands on the same number twice by appealing to some sort of probability, that kind of probability must be an objective fact about the world. It has to be something over and above us and the evidence that we happen to have. Okay. Of course, you might think that that kind of everyday reasoning is mistaken, or more charitably, that it's just sort of a useful shorthand, right? So we can't give a complete explanation of why each roulette ball that we have observed has landed on the particular number that it has landed on, right? That would take too long. So we sort of shorten the story by saying something about probability. Probability is a kind of shorthand that takes the place of what we really think the more accurate explanation is. Or you might think that what's going on in those cases is we're not actually explaining, insofar as we're genuinely appealing to probability, we're not actually explaining why the roulette ball never lands on the same number twice. What we're explaining is why we don't expect the roulette ball to land on the same number twice. Right? So there's a difference between those two facts. We're not actually explaining why we never hit all green lights on our way home from work. We're explaining why we don't expect to hit all green lights on our way home from work. The second kind of fact, a fact about what we expect to happen, those of course could be explained by subjective probabilities, right? So I suspect that what most people who are skeptical of objective probability would say is going on in those everyday cases is sort of this, it's a sneaky situation where you genuinely are appealing to probabilities insofar as what you're really explaining is our expectations regarding certain patterns of events. Insofar as you're really explaining the patterns of events themselves, you're just using probabilities as this kind of shorthand because the real explanation is really complicated. Okay. So you might be able to explain away our use of probabilities in that kind of everyday reasoning. I'm open to that possibility. But I think the very same sort of probabilistic reasoning shows up in our best scientific theories, and there's very good reason to think that you can't just explain it away in that case. And as a result, Insofar as we're committed to the truth of those scientific theories, we are committed to the existence of objective probability. All right, so a little bit of setup before we see the argument in detail, though you guys can probably all tell what's coming now. What I'm going to do is I'm actually going to stop talking about objective probability very much, and I'm going to talk about a specific kind of objective probability called the nomological probability. Okay. Nomological probabilities, as I'm going to define them, are just defined in terms of a certain role that they play. In particular, they're defined in terms of the explanatory role that they play. So anytime you have a true proposition of the form, the probability of an event of type E occurring in a situation of type S is X, and that proposition explains the fact that the relative frequency with which events of type E occur in situations of type S is close to X, then the probability that's showing up in that proposition is a nomological probability. So nomological probabilities are those probabilities that explain associated frequencies. When you know that the nomological probability of something happening is X, that explains why that thing happens roughly X% of the time. Okay, the definition's on your handout, so you can look back at it. It's a little bit of a mouthful. The key thing to remember is just that sort of prosaic reasoning that I talked about right at the beginning. Why is it that fair coins land heads roughly half the time? Because the probability of a fair coin landing heads is 0.5. That kind of, anytime you have an instance of that kind of reasoning, the probability in question is a nomological probability. The reason why I am defining that term is that it allows me to just avoid a whole bunch of other questions about whether nomological probabilities, the probabilities that play this explanatory role that I'm interested in, are the only type of objective probability. So when I present this paper to an audience of metaphysicians who are working on this topic, there are just dozens of objections from people who have their own sort of favorite way of thinking about objective probability. Maybe they're already committed to a specific metaphysical account of objective probability, and it's hard to make sense of nomological probabilities on that account. Or maybe they're really focused on a different kind of theoretical role that they think probabilities play, besides, that is separate from the explanatory role that I'm interested in. Maybe they're really interested in the way that objective probabilities constrain credences. So what they like to focus on is the fact that when we know that the objective probability of the coin landing heads is 1/2, then we ought to believe that the coin will land heads to degree 0.5. We should have credence 0.5 in it landing heads. Right? So what I want to do is just say, insofar as you have, any of you are committed antecedently to a particular metaphysical account of objective probability, or to some other theoretical role that you think objective probabilities play, great. That's not a problem. Okay? Insofar as you can't do justice to those antecedent commitments when you're thinking about nomological probability, then you should think that there are multiple types of objective chance. There are nomological probabilities, and then there's whatever other sort of objective probability you like. Okay? What I'm going to try to convince you of today is that whatever else you think about objective probability, you have to believe that there is, at least in addition, this type of probability. So my own view is that the only important theoretical role that probability plays, objective probability plays, is the explanatory role that I'm talking about here. And so nomological probabilities are the only type of objective probability, but I'm not going to defend that stronger claim. I just want to say one other sort of clarificatory comment. The argument that I'm going to make is that insofar as we are scientific realists, the crucial role that probabilistic explanations play in some of our best scientific theories should convince us that there are nomological probabilities. Okay. So I've said a little bit about what nomological probabilities are and why I'm using that term. I need to say a little bit about the term scientific realism, or what it means to be a scientific realist. All I mean by that, you guys saw a little preview of it just a minute ago, is that we take scientific inquiry to be a good example of successful inquiry into what the world is like. I want to make it completely clear that I'm not saying that scientific inquiry, you do not need to be committed to the idea that scientific inquiry is the only kind of successful inquiry into what the world is like. Okay. Scientific realism is one thing, scientism is another thing. I'm only asking you to consider what we ought to think about objective probability insofar as we are scientific realists, which I take it as a much more plausible view. Okay. The argument for nomological probability goes like this. Consider, just as an example of, not just an everyday example, but one that it's quite clear what our best scientific theories say about this example. Consider carbon-11 atoms. This is a radioactive isotope of carbon that decays into boron. Here's a fact about the world, okay? Undisputed fact about the world. For any particular sample of carbon-11 atoms, around half of the atoms decay within 20 minutes. The standard way to explain one, the way that you'll find in physics textbooks or you'll be taught in physics class, is by way of 2. For any particular carbon-11 atom, the probability of that atom decaying within the next 20 minutes is 1/2. So here's a really easy argument for the existence of nomological probability. Just take that standard explanation at face value. Just say, that's what the scientists tell us, is that we should explain 1 in terms of 2, end of story. Here's another way of arguing for nomological probability. Give me your favorite theory of explanation. Put forward your favorite theory of explanation. Show that on that theory of explanation, 2 explains 1. That commits you to the existence of nomological probability. So insofar as you like either of those arguments, great, you're already committed to the existence of nomological probability. I think there's problems with both of them, right? So again, I'm going to take scientific inquiry as a sort of paradigm case of successful inquiry into what the world is like, but I don't think we need to take everything that the scientists say at face value. Definitely not everything that they say when they're writing their textbooks, right? Because there might be simplifications that are important in that process or heuristics that are important in that process. Also, I think that any full theory of explanation is going to be incredibly philosophically controversial, so it's going to be really difficult to convince people that there is some full theory of explanation that commits you to the view that 2 explains 1. Okay. So if you like either of those initial arguments, great, but I think that there is a much stronger and more convincing argument for the existence of nomological probability, and that is that if 2 doesn't explain 1, nothing does. And 1 is the sort of thing that requires an explanation. So why is it that if 2 doesn't explain 1, nothing does? Because our best scientific theories tell us that the only plausible alternative explanation for 1 is false. So I take it a plausible alternative explanation for 1 is that for any particular sample of carbon-11 atoms, roughly half of them have this feature that causes them to decay within 20 minutes, and roughly half of them lack that feature. Okay. That would be another way of explaining 1 that didn't involve any appeal to probability. But our best scientific theories, our best interpretations of quantum mechanics tell us that that alternative explanation is false. Okay, so on your handout, I wrote down another proposition just to have one to reference. That's 3, right? It's not on the board, but it's on your handout. the thought is that our best scientific theories tell us that 3 is false, and 3 is the only plausible alternative explanation of 1 other than 2. So if 2 doesn't explain 1, then nothing does. That's the first premise of the argument. The second premise of the argument, when I first presented the argument, I put it this way. 1 is the kind of pattern, describes the kind of pattern that requires an explanation. I think a lot of careful maneuvering is going to be involved in spelling out the relevant notion of requires, right? So much more plausible to say that 1 describes this sort of pattern such that leaving that pattern unexplained is a serious theoretical cost. Okay, so it doesn't require explanation in the strong sense that you should give an explanation of 1 even if giving an explanation of 1 commits you to a contradiction or something like that. That's certainly not true. The point is just that it would be a serious theoretical cost to end up committed to the view that there is no explanation for the sort of pattern that shows up in 1. Now, why I think that that's true, I don't have very much to say about this premise, but I do have a whole bunch of things to point to. Okay? And this is one of the several places in the argument where the appeal to scientific realism is relevant. Right? So the thought is that there are many, it is part of standard scientific practice not to leave patterns like 1 unexplained. Okay? So scientists do not just say, look, there is this striking correlation between smoking and lung cancer. Right? There's this pattern. Smokers are much more likely to develop lung cancer. They explain that pattern by positing some mechanism by which smoking causes lung cancer. Right? Scientists don't just observe, that any time they turn the Large Hadron Collider on and they create certain sorts of collisions, they see certain patterns in the little bubble chamber at the Large Hadron Collider. They explain those patterns by saying that the relevant kinds of collisions produce these short-lived and otherwise totally unobservable particles that cause certain patterns in the bubble chamber. Scientists don't just say that there's this regular pattern of some very distant star wobbling just a teeny bit on its axis now and then, right? They explain the fact that the star wobbles on its axis just a little bit with a certain kind of frequency by positing the existence of some otherwise unobservable planet that's orbiting the star. Okay, so scientists are in the business of explaining patterns like 1, and in particular, they're very happy to adopt all sorts of further commitments if they are able to explain a pattern like 1. That suggests that it's part of very standard scientific practice that leaving a pattern like the one described in 1 unexplained is some sort of theoretical cost. Okay? It would be a bad theory if it was just the star wobbles with certain frequency, end of story. Right? Much better theory is the star wobbles with a certain sort of frequency because there's a planet orbiting it. Okay, all that by way of some support for P2. I submit, and I'm happy to talk about either of these first 2 premises more in the Q&A, but I submit that both of these premises are relatively uncontroversial. I think the really controversial premise here is 3, that the theoretical cost associated with leaving 1 unexplained is higher than the theoretical cost associated with using 2 to explain 1. I think that's the crux of the argument. So I'm going to say a bunch about that now. I think the easiest way to argue for P3 is to look at a couple different ways in which using 2 to explain 1 might prove theoretically costly. Okay. So the first way in which using 2 to explain 1 might prove theoretically costly is if it turns out that we cannot give a Humean analysis of objective probability. Okay, so what does that mean? Humeanism is this thesis in its sort of contemporary form. Obviously, it is associated with Hume in some sense, but in its contemporary form is due to David Lewis. Lewis said that Humeanism is the thesis that all that exists is just one little, I'll read the actual quote. He says, "It's the doctrine that all there is to the world is a vast mosaic of local matters of particular fact. Just one little thing and then another." How to understand that view, that all there is to the world is a vast mosaic of particular facts, just one little thing and then another, is a really difficult question, right? But what the view is supposed to rule out, what metaphysicians all agree it's supposed to be ruling out, is primitive dispositional or modal properties. Okay? So you're supposed to be able to give an account of everything that exists without appealing to any sort of primitive dispositional or modal property. You can explain away dispositional or modal properties. To give you a little bit more traction on the idea, probably the easiest way to give a Humean analysis of objective probability is just to take objective probabilities to be frequencies. So all it means to say that the objective probability of the coin landing heads is 0.5 is just to say that the coin lands heads roughly half the time. Okay. And we can see why, if that is your Humean analysis of objective probability, you're not going to be able to use that analysis to give an analysis of nomological probability, right? Because if probabilities just are frequencies, then 2 is just equivalent to 1. All it means to say that for any particular carbon-11 atom, the probability of that atom decaying within the next 20 minutes is 1/2, is just that for any particular sample of carbon-11 atoms, around half of them decay within the next 20 minutes. But how can 2 be used to explain 1 if 2 is just equivalent to 1? Okay. Andy, can you remind me how much time I have?
Let's see, we are probably session should be done 20-25 minutes or so.
Okay. Okay, great. So I'll just mention, very few metaphysicians actually endorse a frequentist account of probability. That's the easiest way to give a Humean account of objective probability. A much more common view is what's called the best systems analysis, right? Where what you do is you look at everything that's true of the world and find the simplest, strongest way of describing everything that's true in the world. The set of propositions that best maximizes simplicity and strength, or those are spelled out in a fairly complicated way that is still supposed to have some traction with the intuitive notion of simplicity and strength. And then you say that any proposition that shows up in that set that captures what's true of the world in the most simple and strong way, those propositions are the laws. Okay. So on the best systems account of objective probability, 2 is not equivalent to 1, but it's equivalent to the claim that 1 is a part of the best system. What it means to say for any particular carbon-11 atom, the probability of that atom decaying within the next 20 minutes is 1/2, is just that 1 shows up in this set of propositions that captures everything that's true of the world in the simplest, in the way that best balances simplicity and strength. Obviously, that needs to be spelled out in a lot more detail. I just mention it here as an example of a very common Humean analysis of probability, and just to illustrate, again, the idea that if you think that 2 is equivalent to the claim that 1 is part of the best system, there's some tension in using 2 to explain 1, right? An intuitive way to put this, things get really tricky here really quickly, but an intuitive way to put this is that if 2 is equivalent to the claim that 1 is part of the best system, then one is at least part of what makes 2 true. Okay. But how can it both be the case that 2 explains 1 and 1 is part of what makes 2 true? You can see how it gets tricky. But at the very least, there's some tension between saying that A explains B and B is at least part of the reason why A is true. Happy to talk about that a ton more in the Q&A, because that is a claim that's currently sort of a hot topic of debate in this area. The key claim that I want to make is not that you can't give a Humean analysis of objective probability. Okay. So insofar as you're still uncertain about what Humeanism is or what the best systems analysis is, right, don't worry about it. The key claim is that even if we can't give a Humean analysis of probability, right, if someone convinced us that it was impossible, we should still accept the existence of nomological probability. Okay? And here's why. Again, I'm just going to point to sort of a very standard practice in scientific inquiry. Right? And that is, scientists are often willing to introduce what would have previously been thought of as metaphysically weird entities if those entities play an important explanatory role. So in slogan form, in science, it looks like explanatory power trumps metaphysical weirdness. So just as some examples of that, you can think of Newton positing a force that acts on heavenly bodies and earthly bodies alike. Right? At the time that Newton was working, that was a radical idea, that the very same force would act on heavenly bodies and earthly bodies alike. That would be a really weird kind of thing to include in your metaphysics. But it played an important explanatory role. It was a very explanatory, powerful hypothesis, so he was happy to do it. Or think about early theorists in the 20th century suggesting that light has the properties of both a particle and a wave. That makes light a really weird sort of thing. But if that's the only way to explain the data, then because that was the only way to explain the data, scientists were happy to accept that sort of thing. A really contemporary example is the wave function that shows up in quantum mechanics. Even today, scientists can't tell you what the wave function is, right? But they are happy to say that there is something in the world that corresponds to a certain mathematical function in their laws because they think that that thing would play an important explanatory role. Okay, so key claim. In scientific practice, explanatory power trumps metaphysical weirdness. Right? Why is that relevant? Again, we're trying to assess P3. The theoretical cost associated with leaving one unexplained is higher than the theoretical cost with using two to explain one. Right? But wait, what if it turns out that the sort of probability that shows up in two is a really weird sort of thing? if we're going to use science as our guide, if we're going to be scientific realists, then it looks like that shouldn't matter as long as it plays this important explanatory role. It's okay if probabilities are a weird sort of thing, as long as they play an important explanatory role. Okay. Here's another way in which it might turn out that using 2 to explain 1 comes with an important theoretical cost. And that is if we can't give any analysis of the probability that shows up in 2 at all. Okay? So we can't even say something like, what are probabilities? They're primitive dispositional tendencies of one kind of experimental setup to have a certain kind of experimental result. We can't even make the connection between probabilities and any more familiar sort of entity that's already in our metaphysics. Okay? We know they're probabilities. They have a certain kind of mathematical structure. Right? We know they're objective because they explain objective facts. We know that they play this explanatory role that I've described because by definition they do. I've just defined probabilities that way. But that's all that we can say. Other than that, they're just sui generis entities. What if it turns out that that's the case, that we cannot give any further analysis of the probabilities that show up in 2? I think that the case here is less clear, but there is good reason, again, if you're a scientific realist, to think that maybe even in that case, you should be happy to use 2 to explain 1, and thus accept the existence of nomological probabilities. Perhaps the easiest example to point to in standard scientific practice is dark energy. Okay? So I promise I won't get into anything complicated. The idea, the reason why scientists posit dark energy is because when they look out at the universe, it looks like the universe is not only expanding, but the rate of expansion is accelerating. Okay. This is a well-confirmed empirical fact. And they cannot explain the rate of acceleration with which the universe is expanding by appealing to anything else that they've already accepted into their ontology. So they posit this further thing, dark energy. Now, in calling it energy, they try to draw some sort of connection to something else that they have already included in their ontology. But if you ask scientists what is dark energy, they tell you, we don't know. We have no idea. Right? Now, they might just be holding out for a metaphysical analysis that's hopefully going to come in the future. But it looks like what they're doing is saying, it doesn't matter if we don't have a story about what dark energy is. The explanatory role that it plays is important enough that we should accept that it exists anyway. So even if dark energy is this sui generis sort of thing, the sort of thing that we can't give any analysis of in terms of more familiar entities, we should still accept that it exists. Because if we don't accept that it exists, we have this fact that we have to leave unexplained that seems like this sort of fact that must have an explanation. So I think that we should accept the existence of nomological probabilities insofar as we're scientific realists, insofar as we take that kind of reasoning to be paradigmatically good reasoning, a paradigmatically successful way of inquiring into what the world is like. We should accept the existence of nomological probabilities pretty much regardless of the further metaphysics that we can give of those probabilities. So there are 3 sort of take-home messages from everything that I've said so far. The one is the message that I just said. It's a very specific claim about metaphysics that all of you should be committed to the existence of at least one type of objective probability, however weird you might have thought objective probabilities were previously, and regardless of what kind of further metaphysics you can give of those probabilities. Even if you don't know anything about the metaphysics whatsoever, right? You know that there's a literature on that metaphysics, you don't know anything about it, it doesn't matter. All of you should still be committed to the existence of these things, insofar as you're scientific realists. The second take-home message is a more general point. about scientific realism, about scientific practice, standard scientific practice, and that is that explanatory power trumps metaphysical weirdness in standard scientific practice. And so insofar as we are scientific realists, in general in metaphysics, maybe in general in philosophy, we should be willing to accept the existence of things that play an important explanatory role regardless of, or even if it turns out that those entities are strange sorts of things that otherwise we might not have wanted to accept into our metaphysics. And then the third take-home message is a really general point. And that is that people often see this sort of people often see the role of metaphysicians with respect to contemporary science as being faced with a certain kind of dilemma. So either metaphysicians are just the handmaidens of science, so they just sort of follow after scientists and like clean up the little details that scientists have left unanswered, or they occupy this kind of radical role of being scientifically revisionary, right? They put themselves in a place where they might come up with something that convinces people that scientific theories are false. And I think one of the reasons why people are so skeptical of metaphysics these days is because they're uncomfortable with that dilemma. They're not sure what metaphysicians are doing that separates them from science but doesn't sort of put them in opposition to science. And hopefully what I was doing today can serve as a good example of the kind of thing that metaphysicians can do. Okay. So they don't just need to take every scientific theory on board without question. They don't need to just sort of follow after the scientists working out the details. They can look at scientific practice for patterns that show up of reasoning that show up again and again, and see how those kinds of patterns of reasoning, like being willing to accept new entities as long as they play an important explanatory role, can be applied sort of outside of the scientific realm to things that don't have as obvious empirical consequences. And I think that that sort of project is a productive project and not a project that is so radical that it sort of turns off most of the audience that might have been available to metaphysicians. So I think that that is a productive way to go insofar as you're working on metaphysics today. All right, thank you very much.